Alright, so the next question asks us to graph and describe the end behavior of this polynomial function, Rx equals negative x to the power of 5 plus 5x cubed minus 4x. Okay, so I'm just going to write this down here. Okay, so the first thing that we want to do is that to graph it, we need to identify the zeros of our polynomial function, right? So we want to identify the values of x, which will make our graph intercept the x-axis. Okay, so to do that, first of all, we're going to factor out x here, or negative x, and we get x to the power of 4 minus 5x squared plus 4. Okay, so we're going to factor this, right? So it'll be x squared minus 4 times x squared minus 1. Okay, you guys can pause the video and you guys can see that these are the factors of this term here. And we recognize here that these are the difference of squares, right? So we can further factor this to be negative x times x plus 2 times x minus 2 and x times x minus 1 times x plus 1. Okay? So we found our zeros, and our zeros are x equals 0, negative 2, 2, 1, and negative 1. Okay? So now we have found our zeros, we can plug them in here. Okay. This is x, and this is y. And we have zeros at 0, negative 1, 1, 2, and negative 2. Okay? Let me draw this better. Alright, so the next thing that we need to know is the end behaviors of our function, right? Because this is going to dictate which way a function faces. Okay, so there's two different options that the function looks like is coming from the positive side to the negative side, or from the negative side to the positive side. So these are the two different behaviors of the function, and they're dictated by the end behaviors, right? So what I mean by end behavior is, how does the function behave when it's approaching infinity and negative infinity? Is the function tending towards infinity, or is the function tending towards negative infinity? Okay, so to do that, to simply do that, all you really need to do is plug in a huge number into your original function. In this case, I'm just going to plug in an infinity, the word, like the concept infinity, into our function, and to see whether or not our function is approaching infinity or negative infinity. Okay, and when you're plugging in infinity, all you really need to do is examine the leading term, because the leading term is what's going to define the behavior of your function. Okay, so if I were to plug in infinity into our function here, right? So let's say, r of infinity. Okay, you guys can plug in a huge number if you want to actually compute what the value is going to be, but I'm just going to say infinity for now. So if I plugged in infinity into our leading term here, we get infinity to the power of 5, which is infinity, with a negative number here, right? So this is equal to negative infinity. Okay, and if you guys want to plug in a huge number, let's say, let's plug in r of 1,000. Okay, so that's not really a big number, but it's something that we can work with. And 1,000 to the power of 5 with a negative is going to be a negative 1,000 to the power of 5, right? So we have found that our end behavior as the function tends towards infinity is coming from the negative side, right? So that means that as our function tends towards infinity, it's going towards negative infinity. Okay? How about the other way around? What if we plugged in negative infinity, or negative 1,000? Okay? If we plugged in negative infinity here, we would get that we would have negative times negative infinity to the power of 5, right? And we know that when a negative number is powered to an odd exponent, it retains its negative sign. So now we have negative to the negative infinity, we have positive infinity. So we have identified that our end behavior for our function, as the function tends towards negative infinity, is that it's heading towards positive infinity. So it's going this way. Okay? So now that we have our end behaviors in sight, we can now draw our polynomial. Okay? So our polynomial, basically, if I were to let me erase this. Okay? So our polynomial will look like this. So I'm going to start from the left-hand side. So when it tends towards negative infinity, it's heading towards positive infinity, right? So when it's heading towards 0, that means that it's heading towards the 0, right? And when it hits the 0, it goes to the negative side, and it has to go towards the other 0, right? And we keep doing this with all the zeros, right? So when it comes to a 0, it will have a local minimum, come towards the other 0, have a local maximum, come towards 0, have a local minimum, come towards the 0, have a local maximum, and come towards the last 0 and have a local maximum, and it goes back down towards negative infinity. So this is approximately what the function looks like. Okay. Now, if we want to accurately graph this function, we have to identify where the local maximums and local minimums are on this function. And to do that, we'll have to find the derivative, and by finding the derivative, we have to find the critical points, and by finding the critical points, then we have to identify whether those critical points are maximum or minimums. Okay, and that's beyond the scope of this question for now, because it asks us to just graph it and to describe the end behavior of the polynomial function. Okay, so we have described what the polynomial, or the end behavior of the function is that the function as it tends towards infinity is going towards negative infinity, and that when it tends towards negative infinity, that the function goes towards positive infinity. So let me write that down and we can move on. Okay, so when x is heading towards infinity, r of x is heading towards negative infinity. And when x is heading towards negative infinity, r of x is heading towards positive infinity. Okay? So this solution is correct. Good work. Cool. All right.